Thank you. It's a pleasure. This is my first time in an international house. I drive by this every day. I live in the North Berkeley Hills, and I drive by this house every day with my children on the way to the Claremont Club, where they play tennis and swim, etc. And we convinced them that pancakes are made here for many, many years until they eventually work out that they're not. So it's finally 10 years we've been here, and I finally get a chance to actually see the beautiful interior and realize there's 600 people in this. It's one of these, like, it's a TARDIS. It looks so small from the front and it's so big from the back. Anyway, I studied physics at Cal, so I feel I have a strong emotional attachment to this place. And today I live up in the, as I said, in the North Berkeley Hills, and although by day I'm a magazine editor, there's still a bit of a kind of, the science engineering guy in me, and there's no better place to explore what science and engineering can do to change the world than Berkeley. And you know that. That's why you're here. But over the past few years, I've been sort of indulging in my geeky hobbies, and they kind of got out of control, and they became a portal into a new movement, I think, in the way technology is being used to change the world. And this has become this will be my next book, which will be coming out in October of this year, called Makers: The New Industrial Revolution. It became a startup company, a robotics company that I now run as a side project, which is now huge and based on a new innovation model called open source hardware, which I'll talk about. And it's part of what I think might be the future of manufacturing in America. Now that's a pretty grand statement, and I'll just hold your judgment until I'm done. But let me talk a little bit about what's changing around us right now, in this campus in Berkeley, in the Bay Area, and around the world. And we can talk about afterwards whether you think that I'm right, that this is a really, really big deal, perhaps the future of the American economy. I'm not in favor of words on slides, so this is it. These are the only words, well, I'm not sure. We'll see. I think these are the only words, but this is my thesis. Basically, what I've come to the conclusion is that the last 20 years on the web, as extraordinary as they have been, as revelatory in revealing and in showing us a new innovation model, new ways to work together, new ways to organize, new ways to structure our society, are just the preview. They work great in the world of bits, of information, of data, of software. But the real world is atoms. Here we are. We've moved our physical atoms into this room. We live in a world of stuff. And the innovation models on the web have been largely of just bits. And just think if we could apply these innovation models to everything else, to manufacturing, to the production of physical goods, to the real world. Just think what a big deal that would be. I've used the phrase industrial revolution, and this is a kind of a big phrase. It turns out when you do research on industrial revolutions, it turns out that no one actually knows when the first industrial revolution started, when it ended. They're not quite sure how many industrial revolutions there are. But broadly, to use the sort of cliched form of the first industrial revolution, it was basically about machines that amplified human potentials. Machine power replaced muscle power. And initially, those machines were spinning wheels and looms of various sorts. Obviously, there was an industrial revolution on the farm with tractors, etc. But the one that we sort of the one that sticks in our head is the steam engine and then the electric motor, which created the factory. It was the notion of big machines creating massive scale production, something that individual people couldn't do. And what the efficiencies of these massive factories could do was to change the shape of production so that the countries that could leverage industrial machineries the best became dominant. It's interesting that these factories, and I'm showing here a picture from textile factory in England. So England became the center of the Industrial Revolution and became the textile producer of the world, which is all based on cotton, even though it didn't grow any cotton itself. What did it grow? It grew ideas. And these ideas were the idea that machinery combined with motive force, combined with efficient supply chains that could collect fabric, sort of the raw fibrous material from India and Egypt and the New World, bring it through a network of ships and trading companies to big factories in Manchester and Birmingham, and then export these clothes to the rest of the world through these same supply chains. This was the British model. This was built on globalization. It was built on capitalism. It was built on the rule of law. It was built on the English language. It was built on these sort of enabling technologies of the global economy. But at the core of it was the factory. So the factory changed the world. If you look at the quality of life of people before the Industrial Revolution and after, what you found is that it's basically, if you look at sort of, the global population was flat until the factory, and then it went skyrocketing up. We lived longer. There were many more of us. We had healthier lives. We were richer, all because machines amplified human potential. Machines turned us from basically, muscle, a workhorse to a mind. And we were able to use our most evolved organ to achieve our potential. There's one hitch, though. And the hitch was that you had to go to the machine. Not only did the factories change the global economy, but they changed the shape of society. They moved people from the rural areas to the cities. They created the cities. Many good things happened, by the way. It turns out when you move rural people to the cities that the houses are drier, that the water is cleaner, that they live longer, et cetera. They can get education, et cetera. But by and large, it disrupted, it changed the shape of society and concentrated people around the machines. And so, and not only the machines, but also the companies that owned the machines. And so we created the sort of the industrial giants, and the kind of thing that in its darkest, elements were the dark satanic mills of the sort of, the worst of the labor abuses. And economically strength, it created the tycoons of the 19th and 20th century. But by and large, the machines changed the world. They changed it for the better and they changed it for the worse, but by and large, the world oriented itself around the machines. Now that is an industrial revolution where we have concentrated power, concentrated physical power, concentrated economic power, concentrated social power. It's about concentrating power. That was a good thing, but that is not the world that we live in today. The second industrial revolution, and people can argue what it was, but I would argue that it was the information age, but not the invention of the computer itself. Although the computer is clearly the enabling technology of the information age, I think what was really important about the information age is that it democratized the computer. It gave the computer to lots of people. And so what it did is it sort of didn't just give computers to lots of people, because that was not enough, right? So if you look at the Apple II, if you get an Apple II, you have a computer on your desktop, and then what? And for many years, the answer was, well, you could program it, and then what? And people kept asking, what's it for? What's it for? And we didn't really have good answers. Now, eventually, we came up with spreadsheets and databases and things like that. But even then, it seemed like a business tool. And for many years, it seems impossible to believe today, but for many years, some of the smartest people in Silicon Valley could not figure out why anyone would want a personal computer. And they kept coming back to the notion of recipe card management. I'm really not quite sure, but that's all they had. And then we came up, and the problem was that although we could all consume computing power, we couldn't really use it to produce. We couldn't really come up with our own ideas, our own products, our own goods and services, and get them out to the world, because we didn't control the means of distribution. We could control the means of production, but not distribution. It turns out you need both. The factory without the British supply chain, the British distribution channel, the British retail power would not have changed the world. You needed both. And so I would argue that there was not just the creation of the personal computer. And then I use the laser writer, by the way, simply because the analogy I want to use is desktop publishing. So that's 1985. That was the first Apple laser writer. Cost $7,000. Interestingly, it had a more powerful processor than the Macintosh that it went with, because it had to run PostScript, which is very tricky at the time. Now, PostScript was the language also spoken or read or interpreted by the largest commercial printers of the world. So you had sort of a commercial quality printer on your desktop, but all you could make was like a church newsletter or like a zine or a flyer of some sort. That was not enough to change the world. You then had to create the internet, and I use a blog as the example, but a publishing mechanism to reach the world, and then we get to the modern web, and then we disrupt the media industry, and I'm in the media industry, and I can tell you that, it was a great thing we had in the 20th century, where we had a monopoly over the means of production, where you had to buy ink by the barrel, and fleets of trucks that delivered rolls of paper and all that kind of stuff. That was a wonderful thing from a profit perspective. It was not necessarily a wonderful thing from the diversity of culture perspective, but the skyscraper we have at 4 Times Square is all thanks to a 20th century monopoly. The desktop publishing and the laser writer was the first chink in the armor of that monopoly, but it wasn't until the blog and the web and the ability for anyone to publish to everyone that we finally lost our monopoly. And we're doing fine, but the newspapers of the world are not. And that's what happens when you democratize the tools of creation and the tools of distribution. So we know that, right? That happened, say, 10, 15, 20 years ago, some combination of, basically that reflects the modern web. So I'd like you to sort of consider that model, production and distribution, and now think about physical stuff. Rather than the desktop printer, laser printer, we have the desktop 3D printer. How many here have heard of a 3D printer? Okay, good. So I don't have to explain what a 3D printer is. And most of you probably recognize the MakerBot. The MakerBot is sort of one of the more accessible of the 3D printers. I'm now on my 3rd MakerBot. My children have grown up with 3D printers. They assume that everyone has the 3D printer, and they complain that ours is too slow. My daughters, they play The Sims, which is kind of like a virtual dollhouse thing where you design architecture and houses and you populate them with furniture, etc. But then they're only allowed 2 hours of screen time a day. So when their screen time's over, they're forced to actually play in the physical world, which they complain about mightily. And but they have a physical dollhouse as well, and so they're like, well, so Dad, I just made the Mad Men scene, set in The Sims. Can we do that in our physical dollhouse? Can you go to Amazon and buy me the furniture? And of course, I'm embarrassed to say that my first instinct is to go to Amazon to try to buy the furniture, but you can't buy the furniture; it's not available, and plus it's expensive, and plus it's the wrong scale, and it turns out that you can't duplicate the diversity, the extraordinary sort of range of options in the virtual world. You can't get that in the physical world, unless you have a MakerBot. So what we do is we go to a place called Thingiverse, which is this repository of designs, and we download the Mad Men furniture, and we print them out on the MakerBot, and we scale it with a little slider so it fits our figures in our house just exactly perfectly, and then we print it out, and they complain that it's green, and it took too long. But we can do it. And, and as we print out our toys, and as our children grow up believing that they should be able to make exactly what they want, and anything they imagine can be produced, and then you think that Kodak just went bankrupt. Kodak, which was built really around film, around the notion that you couldn't produce your own photos, you couldn't develop your own film, and they went bankrupt. Then you start to ask, if you're a toy company today, and you see children growing up believing they can make their own toys, what lessons do you draw from this? Do you really have a future? So we're right where the newspapers, the San Francisco Chronicle had saw that Apple laser writer, they would have laughed, and they said, you've got to be kidding. You can't compete with us. But then you fast forward 20 years, and they were wrong. And now we have the beginnings of 3D printers and laser cutters and laser cutters and CNC machines and all these other desktop fabrication tools are now coming, and they're cheap and they're easy, and we're right at the dot matrix period. Remember dot matrix printers? Remember them? Horrible noise, produced one color. You couldn't believe how awful they were. And now we have inkjets that are beautiful 300 DPI quality that are basically free. Everyone's got one. And you realize that we're right at the dot matrix period with a 3D printer, and that there's nothing stopping us from being able to go to Walmart 10 years, 20 years from now, and buy a 3D printer that prints in any color you want, at any resolution you want, instantaneously in a range of materials, and we'll complain about how expensive the titanium cartridge is, but we'll be able to buy it. And that is, and then you think about Kodak, and then you think about maybe we are onto something here. It's something that really might change the industrial landscape. So that's just making one of things. I can tell you it took 20 minutes to make each tiny chair for our dollhouse. We're not going to compete with China that way. So we're just in the zine period. We're making church newsletters. We're making flyers, for telephone poles. This is not a revolution yet. Where's that distribution component? Where's that element where we can not make one but many? Where's the element where we can not just print local but print global? And the answer is, it's here. The slide on the right is a screenshot from a company called Alibaba. You may be familiar with it. It's basically a website by which you can interface with the global manufacturing. Mostly Chinese companies, Chinese factories. And the interesting thing is that just in the same way I told you about the laser writer. The laser writer it had a super powerful processor because it had to run PostScript. And the reason it ran PostScript is because that was the same computer language used by the biggest printers in the world, and you could prototype your document on your desktop, but then send it to a printer to be printed in millions. Well, now the same thing's happening with physical designs, with CAD designs, is that we now use a global language, G-code, SDL, there's a number of them, but basically the same language that the MakerBot uses is the language that the biggest factories in China use. And you can upload that same design that you make one of, that bunny that you make one of on your desktop, you upload it to Alibaba, and you say, I'd like 1 million, please. And they take credit cards. They take PayPal. It's kind of amazing. The first time I did this, I used to live in China, and I could tell you that in the 1990s and early 2000s when I was in China, if you wanted to get a Chinese factory to work for you, you had to, A, go to China, then there was this introduction, then it involved drinking a lot, karaoke. At some point, you would be forced to eat a fish eyeball. It's a pretty humiliating process. It was necessary. It's a kind of a hazing ritual necessary to make sure that you were kind of, someone they wanted to do business with. If that succeeded, then there was a bank transfer, process, a series of negotiations about the files themselves. So you had to sit down there with the engineer, et cetera. It was hard, and they didn't want to work with the little guys. Now you just point and click. You just upload your file. They quote you a price. You give them the credit card. 10 days later, the box of prototypes show up on your doorstep. If they're good, you just pick what number you want, 1 million. They can drop ship them from China and send them straight to the customers if you want. It's kind of amazing. Technically speaking, the global supply chains are now impedance matched to the individual. It's just like the blog, right? Before the blog, you needed to have a printing press. You needed to have a factory to publish. After the blog, you needed a web browser. We're just that way with manufacturing. Anybody can make anything. And we are limited only by our imagination and, our credit card balance. It's as simple as that. It's kind of amazing. The first time I did this, and I ordered some electric motors. I customized some electric motors. And some robots in China started whirring and making motors for me, and they showed up in a box. And I was like, holy cow. I just sort of hacked the global manufacturing system by just going to a website. It's just a kind of an amazing thing. Anyway, that's the analogy. This is my grandfather. His name is Fred Hauser. He, in the 1920s, he immigrated from Switzerland to the United States. And he was a Swiss engineer, which I think probably on some level made him a watchmaker, right? All Swiss engineers are probably on some level watchmakers. Switzerland, by the way, is the robotics capital of the world. Which basically has to do with little sort of fiddly-geary things, which turns out to be a kind of an entryway to robotics. But this was long ago, and he was kind of a failed watchmaker. He came to Hollywood because Hollywood at the time was a very mechanical business. It was film loops and tape loops, and it was all sort of gears and pulleys and things like that. And so by day, he worked on the initial sound evolution of film, and by night he dreamed of things. He had a work table. He drew plans. He invented. What he invented was this. He invented the automatic sprinkler system. And so if you have an automatic sprinkler system, if you've seen an automatic sprinkler system, that's my grandfather's patent, now expired. Our family's very, very small fortune came from the invention of the automatic sprinkler system. By the way, if you are a Swiss engineer in Los Angeles, that's exactly what you would invent, right? The sprinkler system is the notion of sort of watering system for the green grass that shouldn't be growing in Los Angeles, but does because it's profitable. And if you want to have the sprinkler system run on its own, you'd put a clock on top. And so that's what an automatic sprinkler system is. It's a clock on top of a sprinkler system. And so this was his first one, and this is his patent for it, and little valves and solenoids and timers and things like that. And this is what happened. In the 20th century, if you wanted to change the world, you couldn't. I'm sorry, you're not allowed. You can invent a mousetrap, but the world will not beat a path to your door because you can't make a mousetrap. And even if you couldn't make a mousetrap, you couldn't distribute a mousetrap, or you couldn't make it in any volume. So what you had to do in those days is you had to patent it, and you had to license it to a manufacturer who would then productize it and pay you a royalty. And that's exactly what happened. And Hydro Rain created the Rainmaster so that people could spend more time on the beach with their grass as green as ever. And my grandfather was a massive success story of the 20th century. There was nothing to complain about. He did well. But it's worth noting that he was only an inventor. He was not an entrepreneur. In the 20th century, it was very hard to become an entrepreneur in manufacturing, in making things. You could invent, but you couldn't control the whole process. As I grew up, I spent my summers with him. That's me learning mechanical drawing, 4 or 5. And then as I got older, here's me at 12, I'd spend my summers with him learning how to machine stuff in the workshop. That's a metal lathe. It's a wonderful thing. We'd start the summer, and I'd say, what are we going to do this summer, Grandpa? And he'd say, we're going to make a gasoline engine, 4-stroke gasoline engine. I was like, cool. He said, I'm ordered a kit. And I'd made model airplanes, so I knew what kits looked like, right? You open the box, and there's all the pieces and the instructions and the glue and that kind of stuff. We opened the box, and there were these 4 blocks of metal. Steel, aluminum, brass. And it's like, where are the parts? And he says, they're in there. And there was this blueprint. And over the course of the summer, we basically machined the metal and extracted the parts by following the instructions. And the way a sculptor chips away the bits of marble that aren't the figure, we chipped away the bits of metal that weren't the cylinder and the piston and the crankshaft. And it was kind of amazing to think you could do that. And then I forgot about it for 30 years. I just forgot. And it wasn't until, I had children of my own, and I started to think of projects to do with them, and we got our first 3D printer and some other sort of geeky tools, and that I remembered that, oh yeah, Grandpa had a workshop, and Grandpa invented things, and I wonder if I could invent things. And I thought to myself, why had I forgotten for 30 years? And I realized it's because I didn't want to be an inventor, I wanted to be an entrepreneur. And Grandpa had never been an entrepreneur. Grandpa had been frustrated in his efforts. He never complained, and I'm projecting frustration upon him. But basically, the world had conspired to keep him small, and I didn't want to do that. There's a movie that came out a few years ago called Flash of Genius about a similar situation. This is about the invention of the intermittent windshield wiper in the 1960s. This is a scene just exactly like mine. There's a father who's kind of come up with an idea, and it's the intermittent windshield wiper, by the way, is just a windshield wiper with a delay circuit. So if it's not raining very hard, it delays, and so you can see out the window better. And this guy made a mistake my grandfather did not. He decided that although he was going to patent it, he was not going to license it. Instead, he was going to make it himself. He wanted to be not just an inventor, but he wanted to become an entrepreneur. And so he set out to be an entrepreneur, a manufacturing entrepreneur, a maker of intermittent windshield wipers in the mid-20th century. And this was a mistake. He had to build a factory. So he rented a big warehouse space, and he started buying equipment building the assembly lines, forklifts, all this kind of stuff. Years go by, 1961, 62, 63, 64, he's still not finished with his factory. He's mortgaged his house now twice. Complete an obsession, and he hasn't produced a single one. It's a rainy day. He leaves the unfinished factory, turns the corner in Detroit where he lives, and he sees the new 1965 Mustangs turning the corner to be unveiled for the first time, and their windshield wipers are pausing. And he realizes that his idea has been stolen and that he's ruined, and he goes insane, and the movie spirals entertainingly into his insanity, and that's why it's a movie, etc. And 20 years later, he won a patent lawsuit, and it all ended happily. But there was this lesson for you. Don't try to become an entrepreneur in manufacturing. Don't try to make stuff, because it's too hard. Big factories make stuff. You, sir, can invent, but you must then lose control. You must patent and license. That's the model. That was then. So this is now. This is Tech Shop, which is just down in down 101 in Menlo Park. There's another tech shop in San Francisco. There's a third tech shop down in San Jose. There's one in Detroit. They're sprouting all over the place. These are basically what's called maker spaces. What you're looking at here is basically the tools of production, the 3D printers, the CNCs, the laser cutters, everything else. But of course, they're all attached to the web, so they can also upload and make many. So these are them prototyping. The guy in the front is making wireless control modules for the smart grid. The guy behind him, I have a laser pointer of my own here. This guy here is designing a vapor deposition chambers for synthetic diamonds. In the way back, which you can't see, there's a lunar lander, because why not? And this is, if you go into Tech Shop in San Francisco, which is quite ironic, quite kind of poignantly, in one of the now abandoned warehouses of the San Francisco Chronicle, watching the factory of the 20th century be eaten alive, cannibalized, colonized by the new factories of the 21st century. It's kind of a cheery story of rebirth, I guess. But there it is, where the big reels of paper once were. The new manufacturing entrepreneurs are forming. This is a factory. These people are making the products that you are going to buy tomorrow, and maybe not these people, and maybe not you, but this is the model. This is small manufacturing with global reach. These are people prototyping using desktop digital design fabrication tools, but with the ability to print local or print global, to make as many as they need to serve the model, to serve the market. How many here have heard of Kickstarter? Have you heard of Kickstarter? Okay. Kickstarter is the sort of financial steroid of this market. A lot of these guys are Kickstarter projects. What that means is Kickstarter is a service by which you can solve the financial barrier to entry. What you do is you come up with a prototype, as these people have. You make an entertaining video, you describe it, etc. And then you sort of post a project to Kickstarter, and you say, here's something. If you want it, if you want this thing to happen, if you want it to exist, if you want it to come into reality, please pre-order it, essentially. You basically you support the project, you commit to the project, but you're basically pre-ordering a project. And so you say, I'm making a, what's the most recent one I've supported? A really cool little tracked robot that's driven by an Android phone, or any phone. So I said, that's really cool. I'd love to put my phone, I'd like to have my phone be a robot and drive around and look at the video from the camera and all that kind of stuff. That'd be cool. So I would like that to exist. It doesn't exist at the moment. However, I will pre-order it for $70. I'll commit to spending $70 on it. And if enough people do that, then it will pass its funding target. And then they've just got the money, and they'll go into production, and they'll make it. Now, this is genius in a couple ways. First of all, you basically just move the revenue flow from when they don't need it, which is after they've already spent on all the manufacturing and components, to when they do need it, which is when they need to buy the components and all the manufacturing stuff. You've also done a market test. If it doesn't pass, it probably won't sell. So you've taken a lot of risk. You've de-risked the process of starting a company. And furthermore, you've created a community, and that community is getting updates, and they're bought into the project. They don't just want the project, they want the project to succeed. They want other people to want the project, because only if other people contribute will it hit its funding targets and come into fruition, become reality. And so that, God knows why it took till 2010, I guess, to create Kickstarter, but that's the funding model for the new industrial revolution. Now, it's small now, but Kickstarter did, what it did? It did hundreds of millions of dollars last year in funding. By the way, it doesn't just do physical projects. It's very good at music and film and comic books and things like that. But what's great is that it's scaled around the new entrepreneurial model. So here's the other makerspaces around the world. There's hundreds of them. And all it takes to create a makerspace, or an earlier model was called a Fab Lab, is just a room, a couple of these desktop fabrication tools, and sort of people who want to make things. And they get together, and suddenly you have you've connected inventors in a way that amplifies their ability, not just physically, but also globally. They create online communities, and these online communities surface other people who want the same thing, who want to help, who want to contribute. They build on each other's works. My grandfather reinvented everything from scratch because there was no other way to do it. Today, we build on each other's work. We ratchet our way up into rapid innovation because we are the web age. We are instinctively global. We instinctively collaborate. We instinctively work in public. We instinctively share. That's what's different about the web model, and that's now applied to manufacturing. So, if I was going to build a bumper sticker, it's simply this: making is manufacturing. Making is stigmatized as tinkering, hobbyists, just sort of noodling away in the garage, and that's what it once was for a long time. But now, because it's happening in digital form, because people are designing the products on screen, fabricating one, prototyping one on their desktop, but then manufacturing many by uploading them to various services that will produce them. Now the same act of tinkering becomes an act of entrepreneurship and product development. Making has become manufacturing because it's digital from end to end. And that's the transformation of the maker movement. You can go, if you don't want to buy your own 3D printer, you can go to Shapeways and have it printed in titanium, in aluminum, in stainless steel, in glass, in bronze, in all sorts of resins of various sorts. It's kind of amazing. Anybody can do this. It's like it's like $30 to have something made. It's kind of wonderful. It's beautiful quality. You cannot believe how gorgeous something is coming out of one of these machines. You can have them. You can go to a site like Pinocchio and have them actually sort of combine various parts, do laser cutting and 3D printing, and then source some materials, and then actually drop ship them if you want. Sort of kind of factory in a box, if you will. And the point is that we suddenly, in the same way that in 1985 we all became publishers. I mean, all of you are way too young to remember desktop publishing, but the simple combination of the words desktop and publishing was just mind-blowing. What that meant is that you could publish. Now, what it also meant is that you had no idea what you were doing, right? We didn't know what fonts were, typefaces, leading, kerning, flow, wraparound. This language of page design was totally alien to us, and we made ugly, ugly pages. We made every mistake in the book. 300,000 years of publishing knowledge. The tools suddenly appeared at our fingertips, but the knowledge was not there. We didn't know what we were doing. But eventually we learned. And we're right there with fabricating, with inventing physical things. You can go to a machine shop, or you go to an industrial design shop, or you can go to an architecture school, and they'll tell you about chamfers and splines and G-code and parametric CAD and all this kind of stuff, and it's all gobbledygook. And yet you can download SketchUp for free tomorrow, and there it is on your desktop. So we're all designers now, and it's time for us to get good at it in the same way that we got good at publishing. When the moment, thank you WordPress, thank you Facebook, whatever, we now publish without a thought. And we will soon design and manufacture without a thought. And my fervent hope for my children is that they do a little less learning Excel and Word, and a little more learning SketchUp and 123D or any other CAD stuff. It's time for, they are instinctively 3D. They play video games. They understand how to navigate 3D spaces. This is not hard for them. They should be designing 3D spaces as well. This shouldn't be a sort of a weird thing only for architecture students. This should be for everybody, because they will grow up in a world where everybody has a 3D fabrication device on their desktop. This day will come because it'll be cheap and easy. I don't know what the killer app of the 3D printer is going to be. And by the way, before in the dot matrix era, we didn't know what the killer app of inkjets was going to be. It turned out to be digital cameras. Right. We invented the inkjet before we invented the real use for it, which was printing out your digital photographs. So we haven't figured out what the killer app of the 3D printer is going to be. Maybe it's going to be dollhouse furniture. I don't know, but that's what we're working on. So this is SketchUp, and what's interesting about these free CAD tools right now is that in the last few months they've all started to begin to include the manufacturing component. So you can download SketchUp, and as you always have been able to, make a dollhouse, as we have done here. But what's new is a menu item that allows you to print local on your local 3D printer or print global, upload it to a service to be made in any volume you want, at any quality you want. They're suddenly linked to the web. They're not only linked to the web in terms of production, but they're linked to the web's libraries of other designs. You can download other people's designs and modify them, do derivatives, collaborate around designs. Suddenly, we've taken those laser jets and we've turned them into blogs. And that's the big tipping point. This is another example, Autodesk 123D. These are all free, by the way. This is pro quality. This is a little design I did too as an enclosure for an automatic sprinkler system, by the way. So you download these things, and then you just go up to the Make It menu. So like in your word processor right now, you type, and then you go to the file menu, pick print. This is just the same. You take your CAD thing, you draw, you design, then you go to the file menu and you pick make. It's just the same. It goes from pixels on the screen to something you can hold, but not a 2D paper, it's a 3D object. And not only that, but the difference between the print menu item you have in your word processor and the make menu item you have in your 3D CAD is that you can choose whether you want to output to your local or upload to a service. That's closer in some ways to like a photo utility like Picasa. You download Picasa, it says, do you want to print out your photo on your local inkjet, or do you want to upload it to Shutterfly or whatever and be made into a photo album? Or a book that gets published. That becomes an option. We're right that way with physical goods. You can decide whether you want it to be outputted as one or uploaded and produced at a much higher quality through a service in units of whatever, of an arbitrary amount. Some of these things aren't even software you can download. You can go to a website. TinkerCAD is one, and just do them on the web. This is getting so easy that it's hard for me to believe that the generation, my children's generation, aren't just going to grow up with everyone having CAD skills, the way we all today have kind of absorbed fonts and typefaces and general sort of page design. So let me just end with a sort of musing about what is the shape of this new world where the barriers to entry to manufacturing have been lowered to ankle height. And I think this new world is one that takes advantage of the web's innovation model in a really dramatic way. And the way to think about the web's innovation model for me is to look at a paradox that emerged in the latter half of the 20th century. And the paradox was between these two great men. The guy on the left is Ronald Coase, the University of Chicago economist, who in the 1930s answered the question, why do companies exist? With a theory about transaction costs. So he said, the reason companies exist, the reason we become employed by a company and work together under one roof with assigned functions is to minimize transaction costs, which is to sort of minimize the complexity or the cost of getting things done. Which is to say that when you work together under one roof with a common purpose and assigned roles and responsibilities, you know who does accounts receivable, you know who does accounts payable, you know who does QA, you know who does accounting. And so it's simply a matter of turning to the person to the left or person to the right and asking them to do their job. And that's how we make stuff. We align everyone around a common mission. We know each other. We can talk to each other. We have responsibilities, and we just do it. That's why companies exist. Minimize transaction costs. The guy on the right is Bill Joy, one of the co-founders of Sun Microsystems, and if I'm not mistaken, a Cal computer scientist. And he, in the early 1990s, observed something which is true but quite unsettling. He said, whoever you are, wherever you work, the smartest people in the world don't work for you. And this is actually true. There's not much you can do about it, or there wasn't much you can do about it. By the way, if you think about this too much, you will go absolutely insane, because statistically, whoever you're married to is statistically probably not the right person for you. They're just the person for whom the transaction costs were lowest. Putting that aside, lest I be responsible for divorces tonight. That was sort of, it was true, but was nothing we can do, right? We couldn't hire the smartest people in the world because they spoke Chinese or Hindi or Urdu or whatever. They didn't speak the right language. They didn't go to right schools. They weren't working for competitors. We didn't know how to find them. We didn't know how to evaluate them. They just weren't within our hireable range. And so we settled for the one we're with, right? We're settled for the people who went to Berkeley or went to MIT or went to Stanford, who worked for competitors. We settled for the people who passed the traditional tests of 20th century talent identification. And we are all here because we have all passed the traditional 20th century tests of talent identification, and there's nothing wrong with that. But there are a lot of people who aren't here, who are also talented, who didn't pass that particular 20th century test, and they were the ones that Bill Joy is talking about. They're the ones who were potentially even better than us, but just not findable, not discoverable, because of those accidents of history and culture. And that was pretty much the way the 20th century ended up. And I wanted to suggest that we've resolved that today by applying the web model to everything else. This is the cover of Make magazine. Make magazine is sort of the Bible of the maker movement. And what I'm talking about here, if it's not obvious, is the industrialization of the maker movement. How many people here have been to Maker Faire? Maker Faire. Okay, so if I'm going to give you one homework assignment, this is a university, I'm allowed to do this. Maker Faire is May 20th or 17th, I think, this year. It's in San Mateo, right? I mean, it's just across the bridge. Go to Maker Faire. 100,000 people will be there. This is the maker movement embodied. It will blow your mind. Do yourself a favor. It's a weekend. It couldn't be more fun. They have hot dogs. It's great. Anyway, so the Bible of the maker movement is Make magazine. Actually, it's Wired magazine, of course, but Make magazine started it. And this is the cover of Make magazine a few months ago, and this is about drones. And I just wanted to sort of highlight that person there. His name is Jordi Munoz. About 5 years ago, I got started in all this with a kind of an exercise in failed parenting. One weekend, we get these kind of review, we get products to review that come in the office, and every now and then I'll claim one to do with my kids, and I'll promise to review it. And we got a Lego Mindstorms robotics kit, which was cool. And then we got a radio control airplane, which was cool. And I said, this is going to be awesome. This is going to be like, I was I'd started this site called Geek Dad. And it was all about finding projects that were fun for me and fun for my kids. Not sort of fun for my kids and boring for me, that would be Candyland. Or fun for me and boring for the kids, which would be anything involving electronics. This is going to be fun for both of us. How could we go wrong? Like Lego robotics and a radio control airplane, how could we go wrong? Well, it turns out that children today are completely ruined when it comes to robots. Hollywood has set their expectations so that, like Transformers, right? They think robots should be 3 stories tall and like fire lasers from their eyes. And you get, as those of you who are in engineering know, robots are hard, right? And they don't do that much. And so you do a Lego Mindstorms, you get a tripod, it's a little 3-wheeled thing. And after you spend the entire morning, and we spent the entire morning building it and programming it, it goes forward and then it bounces off the wall and backs up. And they're like, that's it? And like, but I mean, observe how the ultrasonic sensor, detected it's, and they're like, you got to be, where are the lasers? And they were just really not impressed at all. And so I got a little grumpy about my spoiled, rotten kids. And I said, okay, well, tomorrow we're going to fly a radio control airplane in the park. And they're like, that's cool. So we watched videos of people flying, upside down and all sorts of 3D acrobatics. And we went to the park, and literally within 30 seconds, I was in a tree. And so they said that sucked, and I had to bribe them with ice cream, and it was not good. So I decided to I was just angry at them and angry at myself, and it's kind of a failed effort in parenting. And so I went for a run, and I started thinking more about it, and I started thinking about the Lego robotics, the Mindstorms robotics. And it came with these sensors. It came with a gyro sensor, an accelerometer, and a compass sensor, and it had Bluetooth, so you could combine it with a GPS. And it was an ARM7 processor, had a lot of memory, and I thought, you could almost fly a plane with this thing. And so I said, kids, one last thing, let's make a Lego autopilot. And so we sat down around the dinner table, we made a Lego autopilot, and that Lego UAV, by the way, unmanned aerial vehicle, the drone, is now in the Lego Museum in Billund. I'm very proud of this. The children, it kept the children's attention for like a whole nother day. And then they went on to video games. And then I went down the rabbit hole and started a drone company, and today I started a site called DIY Drones and a company called 3D Robotics, and today we make more drones than Boeing and Lockheed Martin combined. And this is the stuff we do. We do quadcopters, we do planes. They're all flying robots. They're all open source. They cost less than $1,000. And this is all because, and I have no training in this whatsoever, it's because I can, right? It's exactly the maker movement at work. I just built a community. They taught me more than I taught them. We did everything in public. It's all open source. We use Arduino, which is the open source computational platform, physical computing platform. And it's like, all of this is possible, thank you very much, Apple, because of the smartphones, and your Wii controllers have these amazing MEMS sensors. So these extraordinary gyros and accelerometers and magnetometers and GPS sensors, which would have been military industrial secrets 20 years ago, to say nothing of costing millions, are now basically available in Radio Shack. So that's what we did. We do full mission planning, basically baseline against sort of military style of UAVs, but we open source them and give them to the world. What could possibly go wrong? And then we decided to start a company to make them, and this was our first factory, which was, as you can see, a garage, as God intended. And today this is one of our 3 factories where we run sort of basically world-class pick-and-place machine lines making electronics. We're a $5 million company in its 3rd year. We have operations in San Diego, Tijuana, and Bangkok with one of our sister companies. And we're now competing with the biggest aerospace companies in the world in the cutting edge of robotics. And Jordi and I just want to come back here. And Jordi right there is now 24. So as I was starting the company, as I started this community, DIY Drones, and I was saying, these sensors are out there. Anybody could do this. Wow, what's possible? Help me out. Kind of learning in public, as one does on the web, and instinctively sharing our learning and our projects. This guy came up in the community, and he was flying a helicopter with a Wii controller, and it was pretty cool. And so I said, tell me more about how you did it, and he seemed really interesting, and we did a blimp together, and we did a couple more projects, and I said, let's start a company. Tell me something about yourself before I make you my co-founder of 3D Robotics, my new robotics company. He said, what do you want to know? And I said, well, anything. He said, well, he was 19 years old, a high school graduate living in Tijuana. And never been to college, still hasn't been to college, had no training in this whatsoever. And today he is, this is a terrible picture, but this is just, today he's running a very high-tech, multi-million-dollar aerial robotics company competing with the biggest aerospace companies in the world, and he still hasn't been to college. So what are the odds 10 years ago or 20 years ago that the editor-in-chief of Wired magazine, when he wanted to start his drone company, would end up with a Mexican teenager from Tijuana? And the answer is, it never would have happened. And it wouldn't have happened not because Jordi's not the best person in the world, he is the best person in the world, but because the talent discovery mechanisms of the 20th century wouldn't let me find him. He didn't go to the right school, doesn't speak the right language, doesn't have the right citizenship. He doesn't have any credentials, he hasn't already worked, doesn't have any experience. What he has is Google. He's smart, he's curious, and he has access to the greatest information resource the world has ever seen. And he taught himself, he gave himself basically a Google PhD. And what's interesting is that even today, as now we're quite a big site and quite a big company, we now know all the smart people in the world. He's still the right person for the job because he's a web native, because he instinctively. So these pick and place machines, this is a automated the solder paste stencil printer, the pick and place machine, reflow oven, all this kind of stuff. We just bought them on the internet. And they'd arrive in a big crate, and then we Googled how to use them, and we asked people, and we're basically just faking. We're just kind of groping our way into this industry, and it's so easy. There's other open source hardware companies that help us. There's so much information on the web. We don't need. Now I realize it's a little perhaps improper in the university to suggest that we don't need a university education to do this stuff, but here we are. But the good news is that we've solved Joy's paradox. We don't have to, the smartest people in the world find us. We don't have to find them anymore. Because we do everything in public, because we're community-based, because we're web-oriented, because we share, we give away everything because we get back more in return, we just do stuff in public, and the right people, the smartest people in the world, come to us. And we could never afford them. So our developers are like guys who work for Apple. They make the iPhone by day, they make drones for us at night. They work for Google, they work for Microsoft, they work, these people, we couldn't afford them. We couldn't hire them. They don't want to leave their jobs. But what they really want to make is flying robots. And they just didn't have an opportunity before. And we created an opportunity. And so in exchange for us helping them live their dream, they help us make products faster, cheaper, better than the aerospace industry, which is the web's innovation model. We know this. It's called open source software. It's called Wikipedia. It's called the web itself, created by us, not by the engineers for us, created by us because we could. And now that's applying to physical things as well, to manufacturing, to products, to the long tail of stuff. So my final slide, my bumper sticker, if you want one, is simply this. Atoms are the new bits. That the extraordinary revolution that the digital revolution began is now going to see its full manifestation in the world of physical stuff. We've just begun. Thank you very much. Thank you. Yeah.